and maybe confirm if I'm audible. Okay, thank you. So I'd like you all to launch your Arc Studio or to open your Arc Studio because I want us to move together. I know people might get lost. Just open your Arc Studio. Okay. As you are opening, I also shared some notes. I don't know if you got via email. I haven't seen anyone responding, but I hope you are able to see the notes. So if you have opened your Arc Studio, I want you to go to File. I don't know if there's someone who is joining. Okay. I want you to go to File. When you click File, you will see this window. Then scroll downwards until where it is written Recent Projects. Okay, you go to File in your Arc Studio. Then there's a window that will appear there. After this window appears, you go to Recent Projects, this one. Then when you go to Recent Projects, you will find a list of projects. It depends with, like for my case, I have several, but maybe for you just have one, the one that we created on, it was on Friday. So click on it. Mine, I renamed it as May class underscore 23. So I'm going to click on it so that it opens. Okay. So when it opens, you can see whatever we were doing last on Friday on basic arithmetic. You can see it all here. Of course, you can always clear the console window. So the beauty of having a project, you get your work organized in a clean environment. That's why it is very important to work in a project folder. Is there anyone? Um, is there anyone who has not managed to open the project that we created last week? It was on Friday. Okay, for those who have joined maybe before I start, go to File, then on File, Recent Projects, then you will get the name of the project that we created last Friday, then you click on it. Once you click on it, you'll be able to see whatever we did. So last Friday, we talked about basic arithmetic, and the objective of this was that for us to see. Yes, Chris. Hello, Chris. I see your hand is up. Okay,
I mean, say that again, how to open a project.
okay. Thank you. Let me just repeat it. Sorry, let me. Okay, you go to file, you go to file. When you click on file, you go to file. When you click on file, there's a pop-up window that you will see. In that pop-up window, you scroll downwards until you see where it is written recent projects. In recent projects, you will get the name of the project that we created last Friday. Mine, I called it May Class 23. So you click on it so that when you click on it, it will switch to a different, like it will open it or it will launch it. So that after launching it, you will be able to see whatever we did last Friday on basic arithmetic. I think that is clear. So today, still we are doing on the basics, and I want us to start on what called basic functions in R. And to handle the basic functions in R, yes, Collins, I see your hand is up.
Hi, Sylvia.
Hi.
Yeah, before we proceed, when we were completing the last class, there was an error that we found, and the explanation. Some my colleagues, I think two or three, gave an explanation on the same, and you said you're going to. So, if you can at least explain it then before you proceed.
Oh, I have remembered it. I think just allow me to respond tomorrow. I have remembered because it was the issue of it was the issue of when you type, for instance, 1 plus, then you execute. Let me see. Let me try to do something so that I can remember. I think this one escaped my. It was something like this, Collins. Then when,
Yes,
for instance, I come back and add a 1 and execute, it gives me a 3 instead of 2.
yes.
Okay, just allow me to respond tomorrow with regards to the
Okay,
same. I think this one escaped my mind here.
okay, sure.
Okay, thank you for reminding me. Okay, I think maybe we can proceed. We can proceed and look at basic functions. And before that, so that your work is a bit organized, I want us to open another script window. So to open another script, let us go to File. Again, let us go to File. I don't know which window am I sharing because when you don't share your entire screen, sometimes your entire screen. Yeah. So go to File. When you open a file, there's this window that pops up with a list of various items. Then click on New File. Click on New File. Then I'm interested in New Script, what you call R script, this one. Or the shortcut of it in your keyboard, I see it is Control plus Shift plus N for you to open a new script. So you click on it. You see there's a new script that has been formed here, indicated as untitled. Indicated as untitled. So, but it is good if we rename our untitled so that the work is a bit organized. To do so, again, you go to File, then Save As, then we give it a name. We can call it function. After that, you save. Yeah, so you can see now we have functions. Our next script is called functions. And before even we define it is good if we understand whatever we are going to cover in functions. The first thing we are going to cover in functions, I think, is structure, the structure of functions. The second thing we are going to cover is there's a function called the log, the log and exponential. Then there's another function called the square root. There's another one called yeah, I think those are the those are the three. Those are the three functions. So let me share my whiteboard. Just a minute. I open my whiteboard. I want to demonstrate something. Okay, I need this whiteboard to demonstrate something. So maybe just a recap is that during our last class, we looked at what's called the arithmetic operators in R. So whatever we are going to look into here is what called the functions for simple mathematical operations. And that's what we are going to look into. These functions we are looking at are for simple mathematical operations. So basically, what we have hundreds of functions included in the standard R program. And these functions mostly cover what we call mathematical operations. They cover what we call graphing, statistical analysis, and so on. So you can get so many other functions, such as for what we call time series analysis. I think when we are doing the beginner level class, I was able to show you some kind of a graph showing time series and many other kind of functions. But the most important thing uh, is for you to know a function. Let me try to type. If you have a function here, let us say you have a function here. This is a function. I won't be writing in full because yeah. So this is a function, for instance. So a function is always followed by what called parentheses. Like a parenthesis is this kind of bracket. This is what called parenthesis. Then inside the function we have what called arguments. A certain function can have several arguments, but other functions do not have these arguments. So the first value, maybe I can call it v1, then comma, then I can again have v2, yeah, then comma, like that up to vn, and so on. So, and since you have opened the parenthesis, you must always close it. So here we are having the name of the function. This is the name of the function. We are having the name of the function here. Then whatever you are seeing here, v1, v2, and so on, these ones, we call them arguments of the function, and you need to know it very well. They are called arguments. Arguments. These are called arguments. Sorry. Okay, it is fine, but I hope you are getting what I want. I'm trying to explain. Then arguments are always separated by commas. Arguments are always separated by commas. So we are going to see like practically what that one means. So these kind of symbols, we don't have such kind of symbols. I was just using to try to explain to enclose, but we don't have. So when we come to R now, so that's the structure of the function. Like as I have said, you have the name of the function followed by parentheses. Then inside the parentheses, you put the arguments of the function in a specified order, and this must be separated by commas. So um, arguments can vary and so on. So it depends. And sometimes, if you omit any options, like when you are inputting the arguments that you omit, what R will do, it will give you by default. And again, as I have said, that if you have opened the parenthesis, you must always close it, and so on. So those are the basics that um, you need to understand with regards to this. When you understand those basics, it will be easy going forward in R or Python or any other language. So, but also a note, you must know that not all functions have arguments, but even though they might not have arguments, it must have opening parentheses and closing parentheses. So I want us now to look at it. The first function, as I said, is the log. Is the log function. So I understand that not everyone came from the mathematical background. So first of all, the log function, you start with log. You see, when you type log, there is a pop-up window that comes, right? As you can see. So the log I'm looking at is the first one. And if you are very keen, you see it is telling me log, open parenthesis, x, comma, base is equals to exponential of 1 and so on. So whatever you need to understand here, first of all, is the function. The function is called log. And inside log, we have what we call arguments. The first argument, like the x, you see, even it has explanation. It tells you what it does. As you have been told, it computes logarithms and by default natural log of 10 and so on. So, and it goes further to explain. So I want to teach you something. For instance, this is the log that I want, the first one in bracket. Then I open the parentheses and close. If you are stuck, if you don't know how to go about it, you can see where my cursor is just after the name log. Before you open the parentheses, I hope you can see where my cursor, like where it is. So I hope, okay. Oh, uh, can the rest hear me well? Please confirm. Yeah, I think, Chris, what you can do, just try to leave the meeting and rejoin again. Try to leave, then rejoin again. Okay. Okay, I think that is fine. So I'm in line number 6 of code. So it is log. So where my cursor is blinking, uh, there, go to your keyboard and press F4. Go to your keyboard, sorry, not F4, F1. Press F1 key in your keyboard. I hope. And if it doesn't give you anything in the help button, you press two two functions, Fn, F1, Fn, F1, Fn, F1. I hope we have anyone who is stuck. When you press F1, you get this description and whatever, how to use it, examples, everything you want. In some laptops, especially the modern generation, you have to press Fn plus F. Let me try to demonstrate. Let me try to. Okay, so it depends. In some laptops, you just press the F1 key, the F1 key. In others, you press Fn, this Fn, this Fn plus, like you press together, F1. Then you'll be able to get an explanation here, the documentation, like everything you need to know about logs, how to use it in R, and so on. Let me see, there's a question. So for yours, then it is all those keys and it works.
Yes, I'm not sure if it's because it's a different version, but when I click on the keyboard shortcuts, it shows the R help is Control Alt F1, but on my laptop I have to press Fn to access F1. Additional to that.
So all this that you have typed here, like you have to press all these. How many keys are this? 1, 2, 3, 4.
Yes.
That's strange. But it varies, depends with the version of the laptop. So far, the ones that I have come across, it is either F1 direct or Fn F1. Anyone else who is facing a challenge or stuck? Okay. what's the issue, Mary?
Mine doesn't work either, even with the Haley's All Sheet F1, F10 F1.
Which model of the laptop?
I am using Lenovo IdeaPad.
Can you try and share your screen first so that we...
Sure. Here.
Where is your cursor? Where is your cursor? It should be before, just after this.
Oh,
Yeah.
just
Then
okay.
and try F1. Yeah, it's
Thanks.
fine.
Thanks.
No worries at all. Any other person who is stuck? Okay, I think we can proceed. Okay, yeah, I'll upload the video. Okay. So I think that is clear, but the most important thing here is for you to understand the structure of the functions, not even the mathematical concepts and so on, because I don't think if you will get them. But the objective of this is you to understand. So, for instance, if I say log 1,000, comma, base is equals to 10. So I have specified. So my argument here, so my function name is log, right? Then after my function log, then 10 so 1,000 is my first argument. Then base is my second argument. So what this means, in a short form, because all of you are not from a mathematical base, what this one means is that for if for how many times can I multiply 10 by itself so that it gives me 1,000 in a simple language rather. So this means that, like for instance, if I multiply 10 times 10 times 10, 3 times it will give me 1,000. So the output should be 3. So that is what it means. But the most important thing there is um, is to understand the structure of the functions. That's the most important thing there. Another one maybe we can look at is the square root. The square root. So what else have you learned is that the log function is inbuilt within R. It's like a calculator. like it remembers, it knows what it does. So we are going also to see on the square root. And when we are talking about the square root, I think when we covered on the power, like when we say 2 times 2 times 2 and so on, that was the square. But now we want to get the square root. For instance, if you want to get the square root of 36, the function for square root is s q r t. That is inbuilt within R. So say if you want the documentation, you put the cursor there and press F1 or whichever function that gives you the documentation. So it gives you the explanation, um, uh, the examples, the details, and so on. But what I want us to look into, let us say I want the square root of 36. The square root of 36 is 6 because square root, like if I take 6 times 6 gives me that 6. So the square root is 6. But, okay, let us execute, we will get 6. But what I want to observe here is that in this square root, right, the argument is 1, right? The argument is 1. I don't know if you have been in on it, like the argument is 1. And our argument, which is 1, is 36, is the value 36. And since this argument is 1, it is not separated with commas. But after the function square root, it has an opening parenthesis and closing parenthesis. So the most important thing, always know a function must be, you must open parenthesis and close. And when you get a function that has so many arguments, it must be separated with commas and so on. Then another thing we want to look into, we have some functions that are a bit funny. There's a function that is a bit funny. Let us take into it. They are called trigonometric functions. This one is a bit funny how it looks like. So there's this mathematical function called pi. Pi is a standard kind of mathematical function, which is 22 over 7, which is equivalent to 3.1, 3.1 something there. Just type pi and run. It will give us 3.141593. So you see this function is a bit funny. It doesn't have parentheses. It doesn't have arguments. What else? Yeah, parentheses, arguments, and commas. So these are the most important thing you need to know in your head. Like when you are talking about functions, what kind of functions are you going to be, and so on. So with regards to this on what we have learned on these mathematical functions in R, I just want anyone to assist us in summarizing what have you learned about function. Leave alone the mathematics, that one does not help us. What is the most important is to understand the structure. Anyone who can summarize for us? Yes, Collins.
Okay. I've learned that for every function that you have to run in R, it should have a closing and opening and parentheses. And then whenever we have more than one argument in a function, the argument should be separated with comma.
Okay, good trial, but I think Collins, there's something you have missed a bit
Okay.
because the last function it doesn't have any parentheses.
Yeah, sure.
Yeah, what maybe we can say majority like of the functions have opening and closing parentheses. Yeah, that is okay. Thank you for the trial. Any other person, anything different or unique that you have learned with regards to functions? Okay. Also, another thing, anything that you have learned in this session apart from the issue of functions, anything else you have learned? Okay. What else you have learned is using scripts. Like you have learned. Yes. There was someone who wanted to say something. There was someone who wanted to add. Okay. So okay, let me check. Yes, we can start with Naomi Musuva, sorry for that.
It's okay. Thank you, Xavier. I think for me with the functions, they almost take up the almost like the generic math group name before anything.
Okay, maybe add more flesh to your point, like
Uh,
add more information.
um, how can I add more information? Like if it's log, that's when you're dealing with like R Studio. If you're using the function log, that log is the actual generic sort of math group.
Yeah, sure.
Yeah, so if it's square, it the precursor is always like the generic math group name. If it's pi, the same.
Okay, sure.
Yeah.
Yeah, thank you for that. There was another hand that was up. It was Michael.
Yeah, I just wanted also to point out the issue of the quick access to the help tab as we are scanning through the functions. I found it very helpful so that I can get different guidelines for each and every function. Okay, I can get a quick way just to summarize notes on how to handle the function. I found that very helpful.
Yeah, sure. Yeah, that's what I was looking at also. So also what we have learned is on how you can get help. When you are stuck, how can you get help? And this is very helpful, by the way, because it gives you even examples. When you are stuck, you are able even to see the examples, how it is written. Each and every argument is explained and so on. So make use of this, the help function also. So I think that is clear. I want us now to look at another subtopic called it is called objects in R. And also in these objects, we are going to open a new script. We are going to open a new script. So we go to file, uh, in the file, we go to, it was, yeah, new file, then R script, which is control plus shift plus N if you like using keyboard shortcuts and so on. So once we open it, it is always good to ensure your work is organized. So we are going to rename it, right? Go to File, File, Save As, then call it Objects. Objects. Yeah, just call it Objects. It's called Objects. Don't add any other information. So having done that, I want to give you just 10-minute break. We come back at 9 East Africa, Nairobi time, like after 10 minutes, so that we look at objects. Or maybe before we go, because we are still having 2 minutes we are having like 2 minutes, because I want us to come back at exactly 9. Whatever we are going to cover under objects, the first one, number 1, is what you call assigning values to objects. The second one is using objects in commands. And the third one, okay, you can say other useful information on objects. Basically, we are going to see objects is what we call variable. And like variables, there is this that you see in most cases. I remember when we were in, is it yes, we are using different education systems, but when you are at what you call secondary school level and so on, there was this joke that people used to say again and again. Why is it that we say let X be so and so and let Y be so and so, and not any other alphabetical letter and so on? So when you are talking about objects and you are talking about, that concept should come into your mind, like you are trying to assign a value to a specific name. So objects are, we are going to see that it is almost like what we call a variable, and that is what objects are. So let us go for a break. We come exactly after 10 minutes, that's 9 East African time, so that we can proceed from there. So we want to look at objects, and I think I have already given like an overview on what it is when you are talking about objects. Let us now try to deep dive and see. I think we can just start from the first one on assigning values to objects. So here, what we want to look into is how we can store maybe values from our calculations and then maybe to use them in further calculations and so on. So we are talking like if you are using maybe a calculator, you can store values and of course use them and so on. So suppose I want to store a value 5 to an object called A. This one, this I can just say A is equals to 5. Then I run it. So when I come and type A, you can see in the console window it gives me 5. I hope that is clear. The first thing, we have created an object called A and inserted the value and equated it like assigned. We have assigned the value 5 to A, and when I type A, it gives me a 5 that I have created. But there's something else I want us to try and see. Suppose I type 5 is equals to A, or let me not, okay, let me use 5, the same 5, so that I try to drive the point home. So when I execute it, it is giving me an error. It is saying invalid left hand side to assignment. So that is what we are getting in terms of an error. So what is happening is that using an equal sign, in assignment in R is not recommended because when you interchange, you get an error. So we can therefore say that most most users of R use what call, do you still remember the dash the dash, let me just try to remind you. There's something I introduced during our first lessons. There's something I introduced during our first lessons. This one, you start with the dash first, this one. Then maybe even you can say 8, and then here B. It looks like an arrowhead or an arrow itself. Or let us say you can start with an object called C, then put this one. So you see, like if you can see this one, when we try to execute them, we won't get an error. So this is called the assignment operator, this one, or this one. It's called an assignment. And these are the operators that are mostly used in R. So the first one, let us start 8 and assign the value. So we start with the dash, then the arrow, we assign the value B. So when I type B, you see, I get my 8. But then when I start with a C, then I assign 10, and when I type a C and I run, I get a 10. So that's why it is recommended, like most of the users of R like using this one assignment, so that even if you are going to interchange it, you are still going to get the response. Like you are not going to get an error as compared to using the equal sign. I hope that is now a bit clear on um, the assignment. But before we go further, I want us to look at what the Art Studio. And in case you have any question, you ask. Sorry. Okay. Oh, guys, can you hear me? Hello. Okay. Yeah, let me just give a recap for the sake of Collins and Michael. So I have introduced what you call objects in R. Objects is almost a variable. In case you did maybe some basic mathematics, you remember your tutor or teacher said let x be equal to 10 and let y be equal to something. You are trying to assign a value to to a certain name or variable, what called variable. That's what called objects in R. So the first thing we have done, we have come up with an object called A, and we have assigned a value of 5 using an operator of equal sign. Right, in line number 7, my line number 7 of code. When I go to line number 10, I do the same, but I interchange. I start with 5, then it gives me an error. And therefore, what we concluded with regards to that is that the equal sign is not the most appropriate one operator in assignment in R, and therefore the best one that is widely used is the dash followed by an arrowhead, this one, so that even if you are going to interchange it, you are still able to get a result without any kind of error. So basically that's what we covered. We are still continuing with it, but there's something very important I want to mention here. Yes, Collins?
Okay, interrupt. When we are using the operator, I realize something. For instance, when we have the C, then add the dash and the 10. So what is guiding us to always arrow after C, not having the arrow pointing to 10?
Yes. What is guiding? Okay. These are operators. Operators are like standard.
Uh-huh.
It is this one is one like is one. It is okay. How can I put it? It's like a standard symbol for assignment. So always the arrowhead should point towards the variable.
Okay.
So for instance, our variable here is C, right? In line number 12.
Yeah.
So you see the arrowhead is pointing towards B. When we go to line number 15, the arrowhead is pointing towards C, which is our variable. So the arrowhead will always point towards the variable.
Okay, thank you.
Okay. Yeah. Any other question before we look at the RStudio's environment. I think it is Elias. So there's someone who has raised hand. Collins, do you still have a question?
No question.
Okay, maybe there's someone I think who tried to raise. Is it Naomi? Okay. In case a question comes up, let me know.
Sorry, it's Savia.
Yes.
I raised my hand. So I'm just trying to figure out. I have inputted as it is, but all of them seems to be giving me an error from line 7.
Okay.
What I missed.
You can read it out.
So error object A not found. Error object B not found.
Yeah, I understand why. The
Why?
main reason,
Mhm.
you see, for instance, my line number 7. First of all, you have to execute line number 7, or you can execute, because if you have not run or executed that line, R does not recognize A. Are you getting it? Like, you have to execute that line that you have assigned before you execute the next one.
Okay, got it.
Yeah.
Yeah, it's worked. Thank you.
I think we can now look at RStudio's environment window. It is just part of this, but it is very important to understand it. So, with our environment window is here. This one, top. This is top right? Yeah. So, what the environment window does, it displays the values of the variables you are using in the environment window. Like, so you see, the variables you are using, the first one is A, which is 5, B, which is 8, then C, which is 10. If you want to clear it, you can as well clear using this icon that looks like a brush. So once you have decided to clear this one, it wipes, like it removes everything. Okay, if I clear it, it removes all my objects. So, for instance, when now I execute, let us say line number 16, just a C, you see, it gives me an error because, in fact, a very big error. I don't have that object because I have cleared all my environment. Until I execute, maybe first of all, line number 15, before now I execute 16. So that now works. So when you clear the environment, it clears everything. So you should be aware of that as well. So that is what I wanted to mention. Another thing that I want us to know is that objects are case sensitive. You understand the meaning of this word I mentioned during our initial classes? When we are talking about objects are case sensitive, what am I trying to communicate? Yes, Hein?
You have to use the same capitalization that you used when you initialized the variable.
Yeah, thank you so much. Yeah. So for instance, we have seen the variable b. Sorry, I haven't executed. Let me execute line number 12 first. 13 as well. Okay. Let me just use variable C or B. Let me use B in my line number 12. Variable B has a value of 8, right? But when I come here and small b and execute, it gives me an error. It is saying that error object B not found. So that means that R is case sensitive, like you cannot interchange like a capital. Yeah, okay, it is okay, Brian. I'll share the recording. So what this one means is that a capital B and a small b are treated differently, um, uh, differently by R and so on. So another thing that we want to look into with regards to objects is using objects in commands. Using objects in commands. And for instance, we have seen A, what was the value of A? 5, right? Then what was the value of B? 8. So if we take A plus, A plus, where is a plus, plus B, it will give us an output as 13. So because A represents 5, B represents 8. When we add 8 to 5, it gives us 13. You can as well try with other arithmetic functions that we learned. Then another important thing that you need to know is naming objects. Uh, okay, given that some of us are already in the industry, who has ever come across a term called audit trail? Anyone who understands the term audit trail? Yes, hey?
Sorry, I meant to make the emoji for yes, I heard it.
Yes? Sorry, I
So
didn't get that.
audit trail is a log of occurrences of what happened.
Yeah, sure, yeah. So audit trail is a log of occurrences of what happens or whatever you are trying to do, like every step that undertook can be traced. That's what you call audit trail. So one is that when you are talking about naming objects in R, is that I can say, like you can name these objects using letters, numbers, full stops, underscores, and so on. But and also they can be as long like a longer names that you want, but they must start with a letter. So one thing is that objects names must start with a letter. This is the most important basic knowledge you need. So it must start with a letter. Another thing is that avoid spaces in between. I don't know if that's the right English. Object names. So what I mean, let me say I have a name called. Let me now use your. Allow me just to use your names. Maybe Collins. Maybe I have a name called Collins Onteri. Then I assign to Collins a value of 5. When I run it, there's an error. And the error here is that avoid spaces in between object names. That's why you can get that error. But when I type, let me copy my line number 34 of code, copy, paste to line number 30, the next line, and where there is, I remove that space, I just put it as one name and run it. You see, there's no error. So when I come and type Collins Onteri, I'll get a value of 5. Yeah. So that one therefore drives us to what you call naming object for an audit trail. For an audit trail. That one drives us here. Yes, is there a question? So, okay. Yes, Cyprian.
Maybe if I can remember, we once said that our studios ignore spaces. So why was it not the case when you spaced Collins and Onteri?
Okay. Yeah, I would say it ignores spaces in numerics.
Okay.
Yeah. It was on numerics, like when you had like 5 times 5, 5 space, then multiply, you put the multiplication symbol and so on. So it was on numerics. Thank you for
Uh,
bringing it up. Yes.
okay.
Okay. Thank you. Yes, Collins.
Yeah, a quick one. When we are assigning objects, so let's say for instance, where we have A and then the assignment operator 5. That means in that in our R, A has assigned a value 5. When you type A, we get 5. What
Yes.
happens now? Interchangeable such that when we type find A,
Collins, I have lost you a bit.
I'm saying when we are running the assignment, when we have A, then
Yes.
5,
Is
then when you come to the next line and type A, we get 5 in the console, right? Now, is it the same as when we come and type 5, can R give us A because we are in the 2?
No. It can't
Okay.
give you. Yeah. Because that's why also we said this statement, there's a statement I have just mentioned saying that in naming objects, names must start with a letter. Even if we start with 5, like we assign A to 5, it won't be possible because 5 is not a letter.
Okay, thank you.
Yeah, sure. So, when you want to name an object for audit trail, even in your data that you are working with in your organization, this is very important. We normally say use descriptive names descriptive names. Always use descriptive names that tell um, tell what values are assigned to them. So this is most important. For instance, if for instance I have data maybe for an insurance company, in this data maybe I can talk of life insurance and so on, and the data has maybe the age of death of the policy holders and so on. So if I want to give that data name, I have various ways. The first one, number one, I can call it age dot of dot death. That's how I can rename it. Or the second option, I can use the underscore age underscore of underscore death. The third one, I can just call it age maybe of death. So what have we learned? First of all, is that this name, yes, we have said it doesn't allow spaces in between, but you can use punctuation marks like the full stop, as you have seen, and the underscores. But it does not allow, or another option, as you have seen in option 3, you can just name it as a whole. Like you can able to name it as a whole. Like instead of spaces and so on, you can just give a continuous name over the same. Then there's something very important as we are winding up this specific subtopic. Note. Remember, we assign a value of 5, right? Yeah, it is 5. Suppose I come up with A, then I assign a value of 15. I run it. Sorry, where is the error? Left hand side. Oh, sorry. I think it is this. Sorry. Yeah. So when I assign A 15 and I come type A and write, it gives me 15 and not 5. That was there initially. I don't know if you are getting my point, because I'm bringing the question back to you to tell me what you have seen about R. Like initially, our A was 5, but I have taken the same A and assigned the value of 15, and when I execute, it returns 15 and not 5. So I don't know who has never spoken in my class. I'm trying to now. Felicia, I understand you joined us a bit later, but I hope you are catching up. What can you tell us about R with regards to this specific example that I have given? Any attempt, Felicia? An attempt, Felicia? Yeah, just try. Just try. That's why we are in class. Like, based on your own observation, what can you say? Maybe someone to assist Felicia? Yes, Dennis?
Could it be because it's the latest value we've signed to A?
Yes.
Because I was just doing the reverse. I signed what you've done A 15 to A,
Yes.
then run.
Yes.
If I do A, I'm getting 15. But if I go back to our initial assignment A, the number 7 one,
Yes.
and run it again,
Yes.
then I'm actually getting it to be 5. So I think it's because it's the latest one, this assignment.
Yes.
Yeah.
Yeah. Thank you so much, Dennis. So, what is that when you are assigning variables in R and you are using the same variable, R overrides, like it takes the value, the current value, and overrides it. So that is also clear and something you need to note with regards to objects in R. Yes, there's a question. Yes, Belinda.
Hello, I don't know if you can hear me, but my question is when you reassign, in case you've done like functions above, let me say like you've done some work above, does it overwrite all that again? Or you can maybe just go back and I check and see if you did it.
So it depends. It doesn't override it what can I like one object that we created. It just overrides a specific one that has the same name or similar. For instance, when you type B was 8. It's still 8. It does not overwritten it so that it is 18, sorry, 15 and so on. But just overwrite the specific one that has the um, same name, same object name as the one that you have input a new value. I don't know if that is clear. Clear. That's Belinda. Oh, I get it. Yeah. So now A plus B, our B is our B is our B is 8. Our A now is 15. So it will now be 8 plus 15, not again 8 plus 5. That's right. Like it picks because everything as for A now is 15. It is no longer 5. But B still remains, it remains 8 because we haven't done anything to it. Yes, there's another hand up. Yes, Michael.
I think just to get some more clarification on what Belinda was also asking, is it right of me to say that it assumes this new value moving forward, but it does not go back to the previous arithmetic and make the adjustment?
Yes. It does not go back. It assumes this. But what you can do, if you want to go back, you go back here. Where is it? it is here. But when you come and write execute this one, it will pick the latest one. So what normal happens, and that's why I took you through the environment window. Can you see the environment window, Michael? Here.
Yes, I can see.
So you
Yeah.
see, A now is 15. We don't have any 5.
Yes.
Yeah, that's why A is 15, B is 8, C is 10. We don't have any other value.
Okay, that's okay.
Okay, thank you. And Belinda, I hope that now is also helpful.
Yes, thank you very much.
Okay. Okay. I think for today, I just want us complete here. I wanted us, but tomorrow we start on. Maybe we can just check on what we will, where we will start at tomorrow, so that we don't forget. We will look at what called workspaces in R, and I want us to get a new script. Go to File, New File, then R script, then after that go again to File, Save As, then it is called Workspaces. Just call it Workspaces. Yeah. So that's where we are starting from. After Workspaces, we will look at what we call them packages in R, and see how far we can go. And also on those notes that I have shared, we have some questions there that maybe you can try and see. I shared last week. It was, I don't know when, but I shared it about 4 or 5 days ago. So any question with regards to what we have covered, I don't know if the team sees the basics as helpful, because based on my experience, the initial units are always very boring. People like now when they reach on uh, uh, like data visualization, data engineering, machine learning, and so on. But all in all, the basics are very important. And I think for anyone who has done a bit of programming, the data science programming is not such technical. I can't even see any kind of programming there. But the basics, I think they are helpful, and they'll play a very good, like it will be a very good foundation going forward. You won't struggle at all if you get the basics right. Yes, Michael.
I managed to download the notes and I realized that they are well numbered up to 15, but from 9 going to 11, is there a file that's missing, number 10 or something?
Oh, this missing number 11.
Number 10, because
Um,
everything was there from 1 to 15, but 10 is missing.
it should be up. Yeah. Let me check. Thank you for bringing that up. Let me check number 10
Okay,
and see here.
okay,
Okay,
thank
thank you.
you.
Yeah, so I want us to close now our project. Who will take us through how to close our project? Who can share his or her screen and take us through how we close our project window? Anyone? Yeah, I'll share that. Hein, I'll share. Yes, Kennedy, do you want to share?
Yes, I want to share.
Okay, you can do so, please.
So, are you able to see my screen?
Yes, yes,
So, if I remember, we come to file,
yes,
then we come to close project,
yes,
then you save selected
yeah, yeah,
the ones that we worked with.
yes,
Yeah. Then after closing, yeah, then now you can go ahead and close it from this side.
yeah, yeah. That is it. Thank you so much, Kennedy, for that. Have a good night, team. In case you haven't done the cut, just try to do. It's just for the sake of practice. I think as at today, about 15 or 10 guys are done. So try to do it. It's 20 minutes.
Yeah, the time was short. By the time I realized.
Okay, sorry for that, Kennedy. Yeah, I noted yours, and of course for Belinda, I have noted the issue. You are saying the internet. There's another person I saw there was there was like you had not selected. It is 20 minutes, guys. So after 20 minutes, the system will just close. Okay. Thank you all. Have a good night. I'll be sharing the recording after the session.